presenter.
I put the last name first. Okay. All right. Okay, you may start when you are ready.
Good afternoon, everyone. And we are LaiChii company that passionate about using simple, sustainable ideas to solve local communities' problem. And yeah, before we start, I want to introduce ourselves first. And then the most right is Isan, Christian, Ko-Eje, Chua Hao-Ming, Stephen, Louisa, and Ricky. And we are now proudly present Clean Air for LaiChii. And now, this is our mission. Our mission is simple. Our mission is to design a low-cost, eco-friendly air filtration system that reduces smoke from LaiChii village in the Timor-Leste without disrupting local communities' traditions. So this is LaiChii village. Next slide. And LaiChii village is a small rural village which consists of 3,000 people. Like others developing communities, they are rely heavily on backyard burning for waste disposal because they have no formal waste disposal and also limited source of it. So this habit will cause thick smoke to occur. And then the effect for the community is that we have a breathing problem, eye irritation, and also serious pollution will occur. So, since banning burning is not realistic, how can we make this practice safer and more sustainable?
Okay, so to answer this question, first we need to listen to the people. Based on our stakeholder, first, homemaker, what they need cleaner home. For the farmer, they need healthy crops. For the medical staff, they want fewer cases about the smoke-related illness. So here come out a message. They need something. What they need? They need something safe, simple, and affordable. So we create LaiChii air filtration system, which is a compact device that attaches directly to the existing burn pitch. It's made from cardboard, sand, gravel, coconut husk, charcoal, and cotton layer. So it can filter the smoke naturally. So the larger dust can be tracked, the toxic can be absorbed. So lastly, the cleaner air is released through the chimney. That's all part of me, and then I'll pass the mic to the Ricky.
So, the true beauty is that it's entirely passive, very easy to use, to a point where the villagers can even build and maintain themselves with simple tools. Our design is guided by 3 pillars of sustainability: environmental, cultural, and finally economic. From an environmental view, it respects and it, of course, cuts smoke and soot emissions, protecting both the people and the surrounding ecosystems. From the cultural view, it respects the local customs by replacing, but not replacing, but improving the open burning rather than replacing it. Finally, with economic view, it cuts costs and uses low-cost and recyclable materials, empowering people to build, repair, and also maybe sell their product to others. So, let's think about this and look at the common problem. Sometimes you buy something sustainable, but it's expensive, hard, and complicated to install. Suddenly you feel this green product is not that good anymore, right? So we came up with some different questions. What if sustainable is cheaper? What if sustainable is also easy to use in the long run? So that's what you see here. Sustainability that pays for itself. It's 90% locally sourced. All the materials, nearly all the materials here can be sourced out of LaiChii. Coconut husk, cardboard, gravel, sand, so on and so forth, can be found anywhere, anytime. Next, it's easy to assemble. Think about IKEA level type of simple, but even better. You don't need a group of experts to build it, and you can just build it with some simple tools as mentioned before. Next, it's easy to maintain. True sustainability is not about a one-time purchase. It's about a product that endures, that lasts for eternity. So, that really costs you to escape from the cycle of constant replacement. Next, so to answer some questions, is it safe to install? Of course. Is it safe? Certainly. So, a product doesn't flourish without any future plans. So, now, our next step is to install some products in homes and village clinics. Of course, followed by some training sessions so that residents can learn and build and maintain themselves. But to some certain point, we do believe that they will even try to innovate and build their own type of LaiChii air filtration system, which we really encourage them to do so. So, the history will be made. Now, the choice is yours. Cleaner air for you and for me, powered by LaiChii. Thank you very much.
So, what is the size of your design?
The intended dimensions for the actual prototype, not the scaled down model, would be a size of 50 centimeters. Oh wait, sorry, my apologies. The stand is variable, and as we have to localize the materials, it's flexible. We can construct it based on the dimensions of the burning pits available. It's not concrete, but extremely affordable and flexible. So there is no set dimension for the product, but an intended height of 50 centimeters to avoid, intended height of 50 centimeters to ensure that it does not affect low-living organisms such as plants, shrubberies, and flowers.
So, is it the intended use indoor or outdoor?
Its intended use is to use for outdoors, as there is no electronics within the prototype itself. It's mainly hollow inside, and there's a air filter on top of it. So it can be used either indoors or outdoors if needed.
How you will control the airflow?
The airflow is controlled with the existing burning pits, such as having a separate hole beneath the prototype itself to draw in airflow instead of the additional holes in the prototype itself to push out. This will cause the heat to dissipate upwards instead of everywhere
How
else.
close it will be to the source of fire? How close it will be to the fire source?
It will be on top of the fire source, so the fire source it will be around 5 or 6 centimeters from the fire source. But due to the existing burning pits there, it will most likely be a ground below where the burning pits will be, where our prototype will stand there with a separate hole on the side.
So, you said you are restricted in terms of height
Yes.
to only 50 cm, right?
50 cm.
Yeah, but now you have this model is on top of other furnace.
Sorry, what was the last section?
You have the furnace beneath this filter, right? So, what is the height of your furnace?
The prototype, intended prototype for Lloyd installation.
No, this one is your prototype, but you are assuming that you have furnace or a place to burn the rubbish before, right?
Oh, okay, our target audience isn't furnaces but open pits, not a not a commercially available furnace. As Lloyd do not have access to such advanced technology, so assume they would advocate such traditional actions.
Okay, so now we are running outside.
Yes.
Your prototype size has a
Effect.
restriction. If you are running in the open air, how now if I want to draw or imagine your design, I
exhaust, as in a pre-available furnace.
Yeah, or at least how we will make sure that the air which is going out of your fire will go inside your machine.
It's installed on the burning pit itself.
Yeah, right. So for example, this is the burning pit. Let's say this is the burning pit, and then this is the rubbish, right? So the rubbish is burned, and then we put it on top of it.
Okay,
Does it make sense? So the smoke goes up, and then there's a filter here, as you can see.
how you can prevent the interior of your prototype from burning?
From burning up.
Sorry, sir, can you?
How to prevent it from burning? You are
So for the real model, it's not for the real model. It's made from clay, and clay is not like yeah.
okay, so it will get dry after a while.
Yes.
Then it's easy to burn, right?
No.
Clay.
Clay is not easy to break. Sorry?
What is the thickness of the clay?
Depends on the size they're making. The size of the size of this filter they're making. If you're making it larger, because like we mentioned just now, the size is variable, right? So if you make it bigger, then you need to make it thicker to support it.
So you have a ratio, for example, diameter to thickness ratio.
Oh, the herringbone thickness ratio.
We're looking at that one. Yeah.
Okay.
Alright, to add on. So the prototype, as we can see here, is made out of cardboard, but the real one is made out from modeling clay. As you mentioned just now, it will get dried up because it's burning. So for future plans and improvements, we are planning to improve our material by using more strong and durable heat-resistant materials such as maybe metal, cement, aluminum. Yeah.
How do we make sure that there's no smoke going from the side?
The clay on the outer layer not only acts as a support system, but it also prevents the soot and dust and dust particles from escaping the prototype.
So, but now when you think the size should be variable and depend on the burning size, right? How they can vary it around?
Oh, it's installed permanently as on top of the burning pit. It's not moved. We do not have any intentions to move it away from the.
How they can access?
Sorry, come again.
If you put it, so you are putting it like that, right? How you will access to put the waste inside?
For future plans, we intend to make a hole, then a door, sorry, a trap door that you can open and dump rubbish in.
With the clay you want to put a door.
That's right. I did not thought about that. Amazing work.
Alright. This prototype itself is technically inspired by the Chinese burning pits that are available to the Chinese. As me personally, I took inspiration from this. So, what my inspiration for this is that there will be the door will be mostly made out of natural metal, but you are able to leave it open. It's able to be left open, as there are some burning pits in some temples that left it open, but the smoke also actually goes upwards into the airflow. From the open doors, it will be pulled in by airflow and then will flow upwards.
So you need to control the airflow.
The airflow will be controlled with from the open doors. So instead of a burning pit in the bottom, let's say for example we have installed a door here. So the
which is existing in our prototype. It's where hot air tends to rise above and the cold air goes below. So when burning quits, the hotter air from the source of ignition flow upwards into the filter, so it will not fail. It's a fail-safe and foolproof system which wouldn't result in malfunctions.